Hey, Algebra 2. All right, here is Unit 2, Lesson 2. We're still with quadratics, but this time we're going to take a look at the vertex form. And vertex form, exactly as it sounds, tells you the vertex. I love how they named these. Vertex form. So just reminder quick about standard form. Standard form, I've got ax squared plus bx plus c. Vertex form, ax minus h squared plus k. So differences here, how to recognize one from the other. Vertex form has one set of parentheses squared. Is it still quadratic? Yes, because if I were to square this quantity, so 2x minus h times x minus h, then this would be x times x, which is x squared. So it is still quadratic. I love the vertex form. I think it is kind of the cleanest formula, and it just tells you so much. So the axis of symmetry, right off the bat, no calculations, is h. Done. Whatever number is here, it's there. Notice the formula is negative and the axis of symmetry is positive. X lies. And the vertex, because this is vertex form, so it tells you the vertex. The vertex is the point h. K, which makes sense because H is on the axis of symmetry. Okay. Notice that A is the same. So A will still tell you, like, if it's positive, I'm going to have a face up parabola. If it's a negative A, I'm going to have a sad parabola, negative, face down or opening down. Okay. So let's see an example here. So if I've got f of x equals, I'm going to do 2 times x minus 4 squared minus 3. Okay, looking at this right off the bat, I've got a happy parabola because a is positive. The axis of symmetry is at not negative 4, because whenever this is, it's the opposite. Axis of symmetry is at 4, and my vertex is at the point 4, negative 3. Now, you don't have to take the time to do that and like identify which pieces. You can make a table for anything you want and fill it all in. But this, I think, helps you to choose the best numbers in your table. So just like we did in the last lesson, I want to put my vertex point in the middle, because if it's in the middle here, then everything around it is going to be symmetrical. So 3, 2, 5, and 6. Okay. So next, what we're going to do is plug in some values and fill out this table. 1 point is not enough to graph a parabola. So let's plug in when x is equal to 5. You could do anything. I did 5 because then this will be positive. 5 minus 4. So 2 times 5 minus 4 squared minus 3. 2 times 1 squared minus 3. 1 squared is just 1. So 2 times 1, 2 minus 3 is negative 1. So when x is 5, y is negative 1. Because a parabola is symmetrical, this is also negative 1. Nice. Okay. And then let's go when x is equal to 6. So it's going to be 2, 6 minus 4 squared minus 3. 6 minus 4 is 2. 2 squared, exponents first, right? Exponents then multiply. 8 minus 3 is 5. So when x is 6, y is 5. Symmetry allows me to also get the point 2, 5. Okay. I need to go as low as negative 3, as high as 5. 1, 2, 3. 1, 2, 3, 4, 5. Out. 1, 2, 3, 4, 5, 6. There we go. Okay, let's plot all of our points. Bump that. So I've got the point 2, 5, 3, negative 1, 4, negative 3, 5, negative 1, and 6, 5. Ooh, there we go. It is, in fact, face up. I have a vertex here at 4, negative 3. The axis of symmetry is right at x equals 4. This is the graph that matches the equation. We did it. Now, to kind of add some challenging questions on here. So let's say I gave you two things about my parabola. Let's say I said the vertex is at point 2, 5, and the parabola goes through point or passes through point 1, 6. I said something like that. And I said, write an equation. Write an equation for that makes this true. Okay, so I'm kind of going in reverse. So for this one, then I've got y equals a times x minus h squared plus k. The reason I want to write this in vertex form and not standard form is because the vertex is in vertex form. If I started with standard form here, I would know nothing. I won't know the y-intercept, so I don't know c. I for sure don't know b. I mean, you can figure it out, but it's quite difficult. Anyway, so I'm going to start with the vertex form here. Plug in everything you know. So a x minus 2, and it's minus 2 because it's positive 2 in the vertex, plus k, 5. And I still have 3 letters here. So in order to be able to just have one letter at a time, I also need to plug in my point. With your point, this one's x, this one's y. So 6 equals, I still don't know a, times 1 minus 2 squared plus 5. Let's solve for a. So parentheses first. 1 minus 2 is negative 1 squared. Subtract 5 both sides. Negative 1 times negative 1 is a positive 1. Whoa. So divide both sides by 1. A is 1. Okay. So let's pop that back up to the beginning where I had plugged in the vertex, and now I can really kind of write an equation. I don't have to write the 1 because multiplying something by 1 is just itself, but for the sake of this, I will. And then let's say as a challenge, the directions say, write my answer in standard form. Standard form means no parentheses, so I've got to simplify this. So this is vertex form. This is perfect vertex form. But in order to get it into standard form, I need to multiply. So x minus 2 times x minus 2 plus 5. We're going to use my distribution property here. So x times x is x squared. X times negative 2 times x, and negative 2 times negative 2. Everything in the first parenthesis multiplies everything in the second. So x squared, negative 2x minus another 2x is negative 4x. And 4 plus 5 is 9. So if I were to graph both of these, actually, let's do that real quick. I'm going to pull up Desmos. They should be exactly the same. That would be your check for something like that. To see if you did it correctly, it would be, did they graph to look exactly the same? So let's check. Hold on, move me over there. Y equals x minus 2 squared plus 5. Oh, it's way up there. And then let's see, this is the big test, is if the second one like lands on top of the red one. X squared minus 4x plus 9. We did it. Great.